Okay, thank you. And I'm going to start sharing my screen. That's the schedule we have right in here. We are right here on the 26th of February 2024. It's 9:40 a.m. Pacific time. And last time we start talking about, let me adjust here the schedule, right? We start talking about electric potential. We finish electric field and start talking about electric potential. And the lab today, we are going to continue with electric field, and there will be also some ideas of electric potential as well. Let's get the students in. More students are coming. And I have some very nice slides. So far, I was what I was doing last time. I was only making a correlation between what you saw about about potential energy, gravitational potential energy, and electric potential energy. That's what I was doing. Okay, there are all sorts of fields out there. Okay, but the two most important are the uniform field and the field of a point source. Let's write it down. Field of a point source. We use those two fields both in mechanics, physics 06, and physics 07. Mechanics has this uniform gravitational field, which is nearby the surface of the Earth, the gravitational field nearby the surface of the Earth, which can be approximated to a uniform gravitational field. And for the case of an electric field, a uniform electric field, which is generated by that configuration, by that electric charge configuration that I showed you, right? So here you go. That's one configuration. That's one configuration of electric charge that generates a uniform electric field. And you saw another configuration of electric charge also results in uniform electric field. And that other configuration is that single planar charge distribution. Let me get that here for you. Okay, so here you go. This one here, single planar, uniform planar charge distribution. You have a uniform electric field on the right side, and you have a uniform electric field on the left side, right? So that's another way of generating a uniform electric field, which behaves quite similarly to the uniform gravitational field nearby the surface of the Earth. Okay? And so let's get here to our notes. The first hour, like I like to do, what do I like to do in those classes? No, first hour I lecture on the Wednesday, right? On Wednesdays, the first hour I lecture, and the remaining hours we conduct the experiment. Okay, the make-believe experiment. We conduct our make-believe experiment. So let's. I started lecturing about the potential energy, electrical potential energy, which I abbreviate as EPE, and then I define the electric potential. Okay, this one I abbreviated by the letter V. Abbreviated by the letter V. In order for you to understand the electric potential, you have to understand the electrical potential energy, right? They are related to each other. That their relation is the following. You go the electric potential energy. The electric potential, and when I mean the electric potential, would be the electric potential of, say, let's say, the charge BQ. Okay, the electric potential of the charge BQ is going to be the potential energy of a charge, and then I'm gonna put like that, charge BQ in the presence of another charge small q. Okay. Potential energy is always related to two objects interacting with one another. That's how potential energy works. And I want, okay, go. And that's going to be potential energy of the interaction between the big charge Q and the small charge little q divided by little q. That's how we define electrical potential. And then you have to understand what electrical potential energy is. At this point in time, you already have, at this point in time, you already have an idea of what potential energy is. More specifically, you have an idea of what the gravitational potential energy is all about. Okay? And this idea extends automatically to an electric charge distribution. Electric charge distribution, okay? So let's review this idea, this concept. And I didn't show that, but I'm going to show you. Let me see if I don't want to start with this one. Yeah, I don't have any choice. I don't have any choice, okay? So let's start with the idea of gravitational potential energy. What I have here on the left half is the gravitational potential energy. What I have here on the right half is the electrical potential energy. How do I know that? Because here I put M for mass and here I put Q for charge. Okay? So here you go. What's the idea of gravitational potential energy? Where whenever I have a mass, here you go. Whenever I have a mass and I raise it against the gravitational force, don't forget the gravitational force is pulling this object towards the center of the Earth, right? When I raise this object against the gravitational field, I'm doing some work. I am doing some work against the gravitational field. And when I do work against the gravitational field, what am I doing? I am pumping energy into this mass, okay? I am pumping energy into this mass. When I let this mass move downwards in the direction of the gravitational field, the mass loses potential energy, okay? That's the idea that you have to keep. It's a very intuitive idea, okay? So you do some effort to raise this mass against the gravitational field. When you do an effort to raise against an object against a gravitational field, not just a gravitational field, but any field whatsoever, you are adding potential energy, okay? Potential energy and energy in general, not just potential energy, is something that's massless. It has no mass whatsoever. Objects like objects, they do have mass, but not energy. So the moment I raise this object against the gravitational field, I'm not adding any mass whatsoever. I'm adding just something else that's massless. Okay, that's energy. That's potential energy. I don't change the mass of the object. It's okay for you to believe that, okay? Strictly speaking, that's not completely true. But in terms of the classical mechanics that we are teaching here, Physics 6 and Physics 7, it's okay to believe that. Okay, later on, someone called Albert Einstein, back in the early 20th century, he discovered that there is a relationship between mass and energy, okay? So much that we have that relation, E equal to mc squared. But we don't have to worry about that now. Okay, for now, we are teaching classical mechanics. In classical mechanics, energy has no relationship whatsoever with mass. Okay, so when I raise this mass against the gravitational field, I am pumping something massless that's called energy, it's called potential energy, that can be used to do some type of work. Okay? The same thing happens when I have a negative charge, just like here in this right side of the drawing. The same thing happens when I have, for instance, a big negative charge and raise a positive charge, a smaller charge, further move this charge further away from the larger charge. Okay? Those two charges, they tend to attract themselves, right? The positive charge, the negative positive charge tends to attract the negative charge and vice versa. So if I'm going to do some work against this force, I'm going to add potential energy to my system. And remember, I'm pumping energy not just in the smaller charge, but also pumping energy into the larger charge as well. Here's the same thing. In the case of the gravitational field, it's the same thing. I'm pumping energy not just in this little mass, but I'm pumping energy simultaneously on the bigger mass and the smaller mass. So the energy has to do with both objects, with our system. Okay? And here's the same thing. Keep in mind that in the universe, people still have not discovered masses that are less than zero. Mass is always greater than zero. So far, we know of no object that has a mass less than zero. Okay, so right? But we do know about electric charges that either greater than zero or less than zero, right? So electric charge is a type of phenomenon that's more complicated, a little bit more complicated than the mass. Okay, so if you want, if you want to increase potential energy of this system here on the right side, I have to separate the two charges. One is negative and the other is positive. I have to do work. You have to exert a force to separate them. If I release them, they're just gonna bang into each other, right? They're going to be attracted to each other, and they're going to lose their potential energy. Just like this mass here. I release this little mass here, and it's going to be attracted toward the larger mass. And all that energy that I pumped in this system, the smaller mass and the larger mass, the potential energy that I pumped into this system is going to be released. Okay? Did you get this intuitive idea? I'm making an effort to separate the two charges. For this reason, I'm adding potential energy to those two charges, to those two charge distributions. Okay, here you go. Here we are subtracting potential energy. I release the mass from a given height. I release the charge from a given height, right? Here you go. And the potential energy gets converted into kinetic energy in both cases. Potential energy here gets converted into kinetic energy. Initial kinetic energy, final kinetic energy. Initial potential energy, final potential energy. So all that idea of conservation of energy also applies to electric charges. Okay? Now, the situation is a little bit different when you have charges of the same sign. Okay? It's the contrary to what you saw before. So this, what you see right in here, you do not have any gravitational counterpart for that. In order to have a gravitational counterpart for this situation that you see here, the two charges have the same sign. Whenever, the only way that you can have a gravitational counterpart for this situation here is if you were to have a negative mass in the universe, which we have yet to discover. Okay? So what's the difference? The difference that when the two charges have signs that are different to each other, you have to separate them to pump potential energy in the system. But when you have two charges repelling each other, like the case of positive charge and another positive charge and a negative charge and another negative charge, you have to compress them together, like the same way that you compress a spring, right? The same way that you compress a spring. When you compress a spring, right? You add potential energy. When you force two charges of the same sign together, you add potential energy to this system. Okay? So that's what, increasing potential energy. Okay, and I release those two charges, and now those two charges they tend to move away from each other. And now in this case, you decrease the potential energy. Did you get the idea? So we can write that down. And to have an intuitive idea, to have an intuitive idea of potential energy, you must think in terms of the gravitational field. You must think in terms first. You must first, right? Think in terms of the gravitational field. Gravitational field, right? When, here you go, example. When you raise an apple against the gravitational field of the Earth, okay, you are doing an effort to do that. Every time you exert a force to do something like that, you add potential energy to your system. In this case, gravitational potential energy. Okay, GPE. And I'm going to copy one of those drawings right in here. More students coming in. Here we go. Gravitational potential energy. Let's see. I have only subtracting. I did something here that I was not supposed to do. Okay, here you go. It's gonna be like that. Subtracting. What is going on here? Adding. I want to put this one at the top. Yeah, here you go. Now I got it. Right? Adding, pumping potential energy to your system. So I'm gonna copy, snipping tool, and paste into my notes. Okay, so here you go. Adding gravitational potential energy, raising a small mass against the field of a larger mass. The apple versus Earth, right? Apple versus Earth, for instance. That's when we add gravitational potential energy. But we also have the electrical counterpart. We also have the electrical counterpart. And I'm going to copy that for you. The one positive charge being raised against the electric force of a negative charge. Like that. Adding electrical potential energy to our system, okay? To our system. And the system is the large charge, the larger charge, and the smaller one. Smaller one. Larger charge, and the smaller one. Separating, right? Separating. And we can also use the same word there in the previous, separating a smaller charge from a larger one, right? So electron versus a larger charge. Instead of electron, let's say proton, right? Because we are talking about the positive charge versus a larger object that is negatively charged. For instance, that's an example. And we can use exactly the same wording that we use right here. I prefer the second one. Adding gravitational potential energy to our system, okay? The larger mass, m, and the smaller one, lowercase m. The smaller separating, right? Separating a smaller mass from a larger one. Apple versus Earth, for instance. However, there is no gravitational counterpart for the case in which we have charges of same sign. In order to have the gravitational counterpart, the masses were supposed to be negative. One of the masses, right? One of the masses of the mass were supposed to be negative. Something that has yet to be discovered. Something that has yet to be discovered, and which is alien to this physics that we teach here. Okay. Now, what I'm going to do, I'm going to do the example for charges that have the same sign. Table right in here. I will copy that other. Yeah, okay, this one that I want to copy. Okay. Increasing potential energy whenever we force two charges of the same sign together, right? Like when we compress, like compressing a spring. So here we go. And we have this other one here. Okay, and that's when we are adding potential energy. Adding. Merge cell. Adding electric potential energy to our system. In both cases, the charges have the same sign. Okay, because of that, we must exert an effort to approach them. Consequently, the electric potential energy increases. Like that. Okay? That's the conceptual idea of potential energy. Once you master that, once you understand that, right, you will understand the electric potential, which, by the way, we can also define a gravitational potential. We didn't teach gravitational potential last semester, but it's possible to define a gravitational potential as well, just like I did in the notes here. Okay? If the electric potential is, you go, is the electric potential energy divided by the charge, we call the test charge, the gravitational potential energy is going to be the gravitational potential is going to be the gravitational potential energy divided by a mass, the smaller mass, okay? Which varies with the distance. But don't forget a uniform field, right? And here for point source. Can you memorize those? That's not difficult, right? You're going to have the notes anyway. During the exam, you will be able to use your notes. Okay. And now it's in real life, like I mentioned before, I'm going to mention it again. Well, in real life, it is easier to measure the electric potential instead of measuring the electric field. Multimeters Any multimeter that you buy out there, they're going to be able to measure the electric potential, which is measured in terms of volts. Electric potential, electric potential energy, just like gravitational potential energy, is measured in joules. J. However, electric potential, okay, which is U divided by Q. U divided by Q is joules per coulomb, right? Is measured in joules per coulomb, right? Just look at the definition. From the definition, you can see that the unit of electric potential, oops, let me erase that, which is V equal to, and by the way, this unit appears so much in physics, show up so much in physics that we give it a name. We call it volts, and abbreviated by volt. Okay. So, and there are batteries out there that have an electric potential. Here you go. Here you go. Here's one of the cells that I have, one battery here that I have. This one is rechargeable. Okay. And you should be familiar with that. That's the smallest of all, the AAA size, right? The AAA size, and this one here is the AA size. AA size, okay? They both have an electric potential, if you're familiar with them. Regular, and let's see, batteries, AAA, AA, and other types of batteries have an electric potential of 1.5 volts, right? But we do have batteries that's more than that, right? There are batteries that can go 9 volts. The battery of your car is 12 volts. And in the past, we used to have the battery that would go in a car would be like 24 volts. Okay. So that's the type of energy, electric potential that those batteries carry. Okay. And how is the electric potential established here? Okay, when we separate the charges, okay, this cell here has a charge separation. Positive charges go here at the top, negative charges stay here at the bottom. So much that you can see a positive sign in my battery. Let me show you, in case that you don't believe me. I'm gonna, let's see, someone is, okay. Let me stop, let's see, here goes. Where my screen is, I believe I showed that to you before, right? Take a look. Let's see. I can't see let me see if I can do that. Well, can you see the positive sign here? For me, it's a little bit, I can hardly see here in my, let me see, stop video, view profile, spot, hide, blah, 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 blah. Yeah, I need a larger picture of mine, but I cannot get it for some reason. But if you know, there's a positive sign there. The positive sign means that positive electric charge, okay? Let's share the screen again. That's what I want to cover with you. Okay, we're gonna do an example. an example of conservation of energy using exactly here you go. Consider the case that I showed to you before, right? The larger charge that's negative and a smaller charge that's separated by this smaller charge, the larger charge. Okay. This big charge Q has a mass M and it's at rest. And is subjected to an initial electric potential V naught. I actually meant lowercase q. Okay, here you go. What's the final velocity of this charge at a point where its final potential is V naught, right? Vf. So suppose at this point here, I'm telling you that at this point, the electric potential is V naught. And at this point, the electric potential is Vf. Okay? What's going to be the final velocity just before it contacts the other charge, assuming that the initial velocity is zero? I didn't put that here, right? Yeah, at rest, yeah, I did say that. Okay, think a little bit about that. You know, this problem is very similar to that of the apple and the earth, okay? It's very similar. We know the initial energy, potential energy, right? Nothing mass at rest of the initial electric potential V naught. What's the final velocity of discharge at a point where its final potential is Vf? Assume that energy is conserved. Okay, all you have to do is to use conservation of energy. So assume that there is no loss in energy, right? So initial electric potential energy plus initial kinetic energy must be equal to final potential energy plus final kinetic energy. We do have conservation of energy. Right? And in addition to that, there is a relationship between the electric potential energy and the electric potential. Okay, and here should be lowercase q, okay? Lowercase q and lowercase q. Okay? Initial kinetic energy is zero because the charge is initially at rest. Right? This one comes from the definition of electric potential, remember? Right? And what do you want to do? Let's say, what do you want to know? What is the final velocity? I want to know the final velocity of the charge just before it collides with the other charge, with the larger charge. Okay. So here you go. That's what I want. That I want that. I know that. I know those two because they're given. I know those two. And move this one to the other side. Okay. We put the Q in evidence. We put the 2 on the other side and divided by m as well. That's the square of the velocity. Right? And then we still have to get the square root. And that's going to be the solution to my problem. Okay. If you were to repeat that for the apple and the earth, right? It wouldn't be much different if you were to repeat that for the apple and the earth. The only difference that we wouldn't have the gravitational potential, but we would have the initial gravitational potential energy and the final gravitational potential energy. Okay, so let's do that. You know, for the apple and the earth. Example for the apple and the earth. The problem would be, change it slightly. Let me get the illustration here. This one that I want, right? I don't want that. I want the other one. Let's see here. I want this one right in here. Okay. This one. Like that. Consider a mass, an object of mass m at rest. At rest. At rest. Instead of initial electric potential, with a potential energy with initial potential energy U naught. What is the final velocity of this mass at a point where its final potential energy is UF? Assume that energy is conserved. U naught here, UF here. What's the final velocity of this mass just before, right, colliding with the larger mass? The larger mass at a point where its final potential energy is UF, assume that energy is conserved. Let me see, I have to state that here too, right? Just before it collides with the larger charge, at a point where its final potential energy is EF. Assume that energy is conserved. So we have exactly the same equation here, right? Now, instead of QV naught, now we are going to write down U naught only, which is initial kinetic energy is 0. Here, instead of QVF, we are going to have UF. Okay. And now just finish writing down the problem. This value goes to the other side, right? Look how the the equations are similar. U naught minus UF, right? We don't have Q anymore, but we do have 2 over M V squared, 2 over M, like that. Compare this equation with the other one, right? Compare this equation with the other one. So one more student coming in. Let's see. Someone is asking, can you scroll up to the worded example for N and M? A little bit more up to the top, Valerie. Tell me when to stop, okay?
Right there. Thank
Okay?
you. Yes, right there.
Okay. Sometimes I take a long time to reply to you because I become so much concentrated on what I am typing. Let's see, there's someone trying to get in. Yeah, Stephanie is trying to get in. Okay. Can I move down? In addition to the electric field lines, we also have the surfaces of equipotentials, okay? That you gotta know as well. So let's start with the equipotential surfaces of a point charge. And right, let's see if we have it here. Yeah, we do have, let's see. Yeah, we do have it. Equipotential of a point charge. Equipotential means exactly what the word states, okay? Equipotential surfaces, right, of a point charge. Equipotential surfaces are surfaces of same electric potential. And you already also know, right? I'm gonna remind you that the electric potential of a point charge is given by, no, that you have to memorize, okay? We cannot derive here in this course. That the derivation of this equation requires calculus, integral, and differential. So just remember that. Right? That's for a point charge. What does it mean? It means that the equipotentials are spherical. Equipotential surfaces are spherical. Are spherical surfaces. Okay? The electric potential here at this point is the same as the electrical potential at this point, at this point, at this point, at this point, and so on. Okay? And let me make this drawing simpler, okay? Because I don't want this appearing yet. This one comes later on. Those are the line of electric fields, right? Electric field vector, which is this one. It's actually this one here. But we can also make a drawing. And here's my electric charge. Let's see. Here's my electric charge. This surface that you see right in here is the first equipotential surface. And the first equipotential surface is given by KQ divided by the distance from the point charge. So it has exactly a spherical, this is exactly a spherical surface. And then you have this other surface, equipotential surface, that's also a sphere, but is a sphere of larger radius. And we have this other surface, this third equipotential surface. And by the way, here is not R2, here is R3, right? I can even go ahead and make a drawing, make a statement, right? That this one here is R1. Radial distance R1. Radial distance R2. And radial distance R3. Right in here. There you go. That's for a positive charge. For a negative charge, you know, the potential surfaces are going to be negative. Now, what about, okay, if you combine the electric field with the equipotential surfaces, you're going to see that the electric fields are perpendicular, are normal to the equipotential surface. That's a very important result as well. We cannot prove that here in this course, but that's something that's not difficult to memorize. You go, the electric field is not perpendicular. We call it normal to the equipotential surfaces. Okay? There's a difference between normal and perpendicular, right? Normal is different from perpendicular. Okay? Normal is a more generic definition of perpendicular. They're related to each other, but the normal is more generic. Okay? Perpendicular means, you know, something is perpendicular to a planar surface. That's what perpendicular means. Perpendicular applies to this type of situation, right? My finger here is perpendicular to the palm of my left hand. But now if I curve my left hand, okay, I don't say, and my finger becomes, let's say, makes an angle of 90 degrees with the tangent of the curvature of my finger, then we say that my finger now is normal to the palm of my left hand, okay? See the difference? Normal is a more generic definition of perpendicular. Whereas perpendicular applies to something being perpendicular to a planar surface, right? Normal means that, you know, when something is normal, to something else, it means that, let's say when a vector, right? Let's say when a vector, whereas applied, let's say, whereas perpendicular applies to a vector, for instance, right? For instance, I'm going to put a exemplify as a vector. For instance, it doesn't have to be necessarily a vector. It can be another plane. For instance, is perpendicular to a planar surface, applies to a vector being perpendicular to a planar surface. Okay, this same vector can be normal, same vector can be normal to a curved surface, can be normal when the same vector is normal to a curved surface, comma, it means that it is perpendicular to a plane tangent to this curved surface. Did you get the idea? No? That's the difference between perpendicular and normal. Now, I'm going to copy that so you can, that's the simplest case you're going to see out there, right? Of the equipotential surface. That's the simplest case. But then we have more complicated ones as well. The spherical surfaces around the point charge are equipotential surfaces. Okay. Equipotential surfaces of a point, of an isolated point charge, But if you have an electric dipole, okay, here you're going to get, it's a little bit more complicated. You see that? It's not exactly spherical surfaces. We don't even have a name for the surface. The surface here is so complicated that we don't even have a name for it. Okay? Those are the potential surfaces of a dipole. One positive and one negative charge. Now, in the case of a uniform electric field, let's take a look at the case of the uniform electric field. The equipotential surfaces are going to be planes that parallel to the charge distribution. Let's say that there is no, assume that there is no edge effect, okay? Assume that there is no edge effects. Here are the electric fields. And the electric field is exactly uniform. See here, that's one plane, equipotential plane, that's another equipotential plane, and so on. And that's the type of result that we get for the experiment, right, that we're going to finish today. And here is the case of a linear charge distribution. In the case of a linear charge distribution, we also have equipotential surfaces. And if this charge is long enough, this linear charge, can you picture that? A linear charge, a charged line. Suppose that we can create a charged line that's long enough. The equipotential surfaces are going to be cylindrical. Okay, one cylinder here, another cylinder here, and so on. In this case, the electric field decreases as you move as you go further and further away from the linear charge. Remember, right? Electric fields, they always decrease in magnitude as you move further and further away. Okay. 10:40, we have 1 hour. Any questions about that? I'm going to take attendance right now. This is our third lab meeting. And Abir Ahmad.
Yes.
Oh, okay, you're here. Thank you.
Yes.
And Nestor Alvarado. Let's see if Nestor is here. Yeah, I see Nestor here. Hey, Nestor, are you there? Looks like he walked away from the computer. Next is Monte Ambarchian.
I'm here.
Okay, thank you, Monte. Next is Hasti Amin. Are you there, Hasti?
Yes.
Thank you. Hasti just joined us, right?
Yes.
Okay, thank you for joining us. Here goes Isabella. Isabella Ballestero. I don't see, let's see here. Oh, Isabella didn't come any of the meetings, huh? Next is going to be Justus.
Hi, Professor.
Hi, hello, good morning. Thank you for answering.
Good morning. Of course, anytime.
Okay, Alexandra Barmistrova. Let's see, is Alexandra here? Alexandra. I don't see her. Okay. Next, Benjamin Carvajal. I don't see Benjamin either. Brianna. Okay, thank you, Brianna. Elizabeth Castellano.
Here.
Thank you, Elizabeth. Natalia Cordoba. I don't see Natalia in my list. Jacqueline Delgadillo. Hello, thank you, Jacqueline. Next is Jenny Diaz.
Here.
Thank you. Valerie Diaz.
Here.
Next is Juan Escalera. Thank you, Juan. Bianca Eloki.
I'm here.
Okay, I got your emails. Okay, Bianca, but I still didn't have time to reply to you, but I will reply soon.
Yeah, no worries. Thank you.
Okay, thank you. And thank you for your search there on the case of the calendar, okay?
Of course.
Okay, thanks. Dana Gomez.
Here.
Thank you. Edwin Gonzalez. I see that Edwin is here.
Here.
All right, thank you. Ellie Gonzalez.
Here.
Thank you. Next, Manuel Hernandez Pineda.
I'm here, Professor.
Thank you. Samantha Hubert. Samantha, let's see. I don't see Samantha in my list. Faiz Hussein. I don't see Faiz Hussein here. CJ Joseph Hutton. Is CJ here? I don't see CJ. Next, Luis Leal. I don't see Luis Leal either. Amber Lopez. Hello, Amber. Amber is here, but it's not answering. Let's go. Arely, Elizabeth Lopez. I don't see Arely. Yeah, I don't see Arely. Next is Genesis Lopez.
I'm here.
Thank you. Mary Michaelian.
Here.
Thank you. Ramon Olivares.
Here, Professor.
Thank you. Next is Taylor Forn.
I'm here.
Oh, thank you, Taylor. Next is Jeremy Pittman. I see Jeremy here.
Yeah, I'm here.
Okay, good. Did you solve your problem
still
there with the book, with the?
No, that was what I was gonna say. We don't have the correct ISBN number for the Wiley Plus
Yeah.
software.
Okay. Okay, let's talk about that at the office hours, okay?
Okay.
Okay, Stephanie Ramos.
I'm here.
Thank you. Leslie Alexandra Rios.
Here.
Jason Strait.
I'm here.
Thank you. Gemma Torres Navarro.
I'm here. Good morning.
Thank you. Good morning. Cindy Vieira. I don't see Cindy here. And Nuhamin Wanimu. Doesn't look like Nuhamin's here either. And we have a total of 24. Two students. Amber, are you there? One more chance. And Amber and Nestor. Oh, here you go, Nestor. Thank you, Nestor.
Wait. Yeah, no worries.
What do you say? Okay, so 10:48. And let's take our break now. Break. Now let's do 10:50 a.m. To 11:05. Okay. And I see you in 15 minutes. Okay. See you then. Stop sharing. I am back. And now we're going to do we're gonna work on the spreadsheet, right? And I want you to download the spreadsheet to your laptop. The one you have in Canvas. Okay, and let me that's Canvas here. No, that's not what. Let me see. Yeah, okay. So does everybody have the spreadsheet? Yes, everybody seems to have the spreadsheet here, right? So go ahead, download that, okay? And I'm going to help you out throughout this lab. And we're going to work together on that. I'm going to call you every now and then. And what are you doing here in this lab, right? If you remember what I was explaining to you, in this lab, we are measuring the electric potential at a specific places in our conductive / resistive paper. That's what we're doing. And creating equipotential surfaces. That's basically what we're doing, right? Remember what I told you. It is much easier to measure an electric potential than compared to an electric field, okay? So in this experiment, first, we determine the positions of a specific equipotential surfaces. And from these surfaces, we determine the configuration of the electric fields. That's the idea of this lab. Right? So look, let's go ahead and get our spreadsheet. I'm gonna get just one, at random here. Lab reports. No, it's not that yet. Lab, raw data. So let's see, I'm gonna get lab number 10. Oh no, that's not what I want. I want this one here. I'm gonna get the group 9. And here are the data for this specific spreadsheet. Okay, so you're going to have a table. You can ignore this row. One day I'm gonna delete it from here. I haven't done that yet, but keep it there. Don't delete it. Don't change anything. My spreadsheet. Don't change the order. Let's see. Don't change the order of the cells. Okay, because I need the cells to be in this order. Please do not change the order of the cells, and do not delete them, and do not delete them either. Delete them either, please. Okay. I need the spreadsheet specifically in this format so I can correct it. We will be doing other things, to this thing, and so what we have. Take a look what we have in there. I have the volts, X and Y coordinates of my spreadsheet, right? Just like I covered with you last time. Here you go. Something like that, okay? Something like that. That's, I need to change this thing. 2, 4, 6. Let's see. Yeah, you have 2, right? 4, 6. No, it's not gonna work. I'll leave this way. 2, 4, 6, 8, and 9. Okay, 2, 4, 6, 8, and 9. Let's do that. 2, 4, 6, 8, and 9. Right? It's better this way, so it's consistent with what you have in your spreadsheet there. Okay. And I will change that here as well. 2, 2. That's it. 4, 4, 4, 6, 6, and 6. Already have 6 here. What about here? Ah, I've got to change that too. Oh man, that's too much work. 6, right? 6, 6. Make it consistent with whatever you have there. 6, 6. Okay, and we start with 2 here. Supposed to be 2 as well. Ooh. Good. 2, 2, and someone else is trying to come in. 2, 2. Oh, it's gotta be 2 here. 2, 2, 2, 2, 2. Wow. 2, 2. Yeah. Now 4. 4, 4, 4, 4, 4, 4, 4. And I need to start recording, right? Let me see. Can I format the cells to number? You can format, yes. What you cannot do is move the cells around. Okay, you can format. You can, put the right number of significant figures and so on. But let's. What we want to do now. Am I recording? Let's see if I'm recording. All recording. Yeah, it looks like I'm recording. Okay.
I think you were already recording, Professor.
Okay. Am I right?
Yeah.
Okay. Thank you. 4, 4. Okay, now next one is 6, right? Here's gonna be 8. Should be the last one now. 8, 8, 8, 8, 8, 8, 8. Okay. 8 here. 8. Oh, one more here. Okay, good. So that's what you have for now. And then what you have to do. The first thing that we have to do, just look at what you have to do. You have to fill up the units, okay? Those 3 rows here already have the units. Volts, position in meter, position in meter, okay? And you gotta do the same here. It's not much difficult, right? Not much difficult. So what do you have here? You have a bunch of data, and we want to plot this data in the X and Y coordinate space. Okay, that's what we want to do. So, I'm gonna teach you how to do that. If you want to find out the equipotential of 2 volts, what do you have to do? You have to highlight those 2 columns. Okay, let's start by plotting the thing. So here you go, highlight those 2 columns. Later on, we worry about the significant figures, okay? Insert, we go to chart, scatter. Okay, here you go, we got it. We got our first equipotential. Okay, here is 0, here is half of a centimeter, 1 centimeter, 2 2 centimeters, no, 1.5 centimeters, 2 centimeters, 2.5 centimeters, and 3 centimeters. That's what it is, okay? Don't forget this thing is all in meters. So let's go ahead and plot. Let's do exactly what I did, okay? That's gonna be my first equipotential at 2 volts. I'm gonna do that again in case you missed it. This one is gonna be a little, different than the other graphs that you ever plotted in your life. This one, is gonna be a little bit more tricky, complicated. Okay, so here you go. Highlight the X and Y coordinates. Whatever is to the left is going to end up in the horizontal axis. Whatever is to the right is going to end up in the vertical axis. You click on insert. Once you have clicked insert, look for the chart panel. The chart panel is this one right here, and you're going to plot the scattered like that. Everybody got it? But I'm going to go through the class one by one. Make sure you're still there, okay? Abir, are you there? Abir Ahmad? First step here is to plot the graph, okay? That's what I'm going to write here. First, plot the equipotentials of the graph. Okay, doesn't look like Abir's in there. So, like I said, download, okay? I'm gonna put a 0 here. A 0, no, oh, Nestor, are you there?
Yeah, I'm trying to figure out what chart did you want us to do it on?
Okay, so did you open the graph already? I need to know that you opened the graph first.
Yeah, I'm already kind of following your steps.
Okay, good. So you open the spreadsheet. So the next step, okay, is to plot the graph. Okay, so how do we plot the graph? We go, here you go. I'm gonna erase, start from scratch, right? Highlight, oh, we are at 2 volts right here, see that?
Yeah.
Okay, highlight X and Y. The column X and Y, only the numbers. Insert, click on insert at the top of the spreadsheet, top left, and look for charts, okay? Here you go, charts. In this class, all the time, we're going to use this graph here, scatter, with no lines connecting the points, okay? That's what I want you to do. Do you do that?
All right. Yeah, I got it already.
Okay, good. And then second step, there's a total of 1, 2, 3, 4, 5 steps, okay? That's for everybody, right? And what's going to be the second step? You click one of the points, follow with me, okay? And every point is going to be highlighted. Right click it, and then you select data, okay? Select data. Note, see that your first data points is series number 1. You can even edit this series number 1 and write it down, 2 volts, okay? That's the equipotential for 2 volts. And now what you're going to do, you're going to add another set of data points. And this other set of data points is going to be the equipotential for 4 volts. And then one more thing, series X value, okay? The X value for 4 volts. The X value for 4 volts is this column right in here. Just highlight it, and automatically Excel fills up for you the cells that is going to plot. But we need also the values for the Y values, the series for the Y values. The first thing you do is to erase completely what you have here, right? And then you highlight the Y values at 4 volts, okay? Do you see here the equipotential appearing?
Yeah.
We have the equipotential for 2 volts and the equipotential for 4 volts, right? So Nestor, he managed to do that, right, Nestor? You download,
Yeah.
oh my goodness. Hey, but I forgot to click OK. I gotta click OK, okay? Let me get out of here. Click OK. Don't click OK again. Just keep this window right in here. We're going to do the same for 6, 8, and 9 votes, okay? One more student. Here we go. Now I'm gonna go for the next student in the, let's see. Monte, are you there, Monte? Oh, I need to click OK here.
I'm here.
Okay, did you open your spreadsheets, Monte?
Yes, I did.
Okay, good. So did you plot your first equipotential line?
Yes.
Oh, you did, okay. And Nestor also did that. Did you plot your second equipotential line as well?
I'm doing that right now.
Okay, you're doing that right now, okay? Now, and then you repeat that for the other ones. Click one of the data points, right click, and then select data, okay? I'm gonna document here in the notes. Plot the equipotential of the graph, okay? So first equipotential, you highlight the X and Y coordinates of the 2 volts data. Okay? Highlight X and Y coordinates. B, click insert. Go to graphs. Graphs or graph? Let's see. Let's see if it's plural. Insert. Charts, not graphs, it's charts. Go to chart. Go to charts. And click on the insert scatter. Okay? Insert scatter. If you put your mouse, to any of those drawings, right? Any of those icons, you're going to see which one is which. Click on insert scatter. Click, go to charts and click on insert scatter. D. Next, right? And then you choose the very first scatter plot with no lines connecting it. Choose the very first, choose the very first scatter plot with no lines connecting points. Okay, you plotted your first equipotential. You plotted your first equipotential. I'll click OK, right? Click OK. You gotta click OK twice. And you plotted your first equipotential. First equipotential, and then I'm gonna put this one like that, Here you go. Organize better. Here you go. Plot second equipotential. Plot, let's see here. Plot first equipotential. Like that. You highlight the X and Y coordinate of 2 volts data, right? Now I'm going to plot the second equipotential. I already did that for you. Let's do that again. Here you go. I'm going to document it here. Click one of the data points of the graph. Okay. Everything should be highlighted. Every point should be highlighted. Okay. And the third equipotential is similar to the second. Okay. It's just a repetition. Here you go. I'm going to click the equipotential, right? Everything is highlighted. Since everything here is highlighted, the Excel shows up the columns that were plotted. Now you're going to choose right click, select data. Okay, here you go. Right click. From the drop down window, select right in here. Yeah, let's see. Oh yeah, select data. Okay, let's do it again. Here you go. Right click, select data. On the drop down window, select data. Select highlight, right? Highlight. Select data. So let's continue. Select data. Now we're going to add, right? The 4 volts. Add. I'm just gonna repeat what I did before, okay? The 4 volts equipotential. Series name 4 volts. Let's go there. Drop down, select. Okay. Click add button. Click add button. I'm going to remove this one for now, just to repeat, right, what I did. Add button. On series name, write down 4 volts. On series name, write 4 volts. Okay. Click on X series, is that right? Let's see. Click on series X values, hit 4 volts. Series X value on series X values. Highlight the X values corresponding to the 4 volts equipotential. And that's what we're going to do here. Ego X. Everything has been highlighted. Now, the coordinate of the points in the cell is highlighted. Next, erase everything the series Y values. Erase everything in the series Y values. Highlight Y values corresponding to 4 volts. The 4 volt equipotential. Y values corresponding to the 4-volt equipotential. Click OK. Click OK. Click OK. Click OK. And then what else do we do? Repeat the steps B, I through step B, lowercase I, BI through B12 for the remaining equipotentials. Okay. So let me finish it here. Click to highlight, right click, select data, add 6 volts, X series, select the data correspond to the X values, select the data correspond to the Y values. Now we have 6 volts. Click OK, click OK. See the equipotential, how they are shaping up to be? Here, this is the edge effect, right? That I mentioned to you before. It curves towards the edge, the closest edge of the plate. Here you go, 8 volts. Highlight, select data, add 8 volts, X value, Y value, okay? Click OK, click OK. And last but not least, right? Click here, right click, select data, add 9 volts, X values, those one here. Erase whatever is in the Y, select Y, click OK, click OK. So you should have a graph like that with your equipotential surfaces looking just like that. Okay. And let's see if anybody else has any problems. Next one here is Hasty. Did you manage to do that, Hasty?
Yes,
No problem.
no problem. Thank you.
How many equipotentials have you done so far?
Three or four.
Three or four. Okay. You have to do all the 5, right? 2, 4, 6, 8, 9, 5. 5 equipotentials, okay?
Okay.
So Isabella arrived? No, Isabella didn't arrive. Justus. Are you there, Justus? Okay, I'll get to you, Ramon. I'll get to you. Which group group do you have there, Ramon, in the spreadsheet?
I figured it out. Yeah, it's just different because I'm on the Mac.
Yeah, it must be because you plotted only one equipotential. As you keep on plotting the remaining equipotential, they start to look like the way it's supposed to look, right?
Yeah, correct. Yeah.
That's what happened. Yeah. Are you there, Justus? Looks like Justus is away from his.
Wait, hello? Hello?
Okay.
Is it working?
Yeah, I can hear you. Good.
Okay, sounds good.
Okay, good. Did you download your spreadsheet?
I did, yeah. I'm part of G1.
Okay. How many equipotentials have you plotted so far?
I've plotted about only just 2 so far.
Okay, 2. Okay, good. Thank you.
Of course.
Alex, thank you. Let's go to the next student. Alexandra is not here, right? Beer. Okay, Abir replied to me. Okay, I'll get back to Labir. Benjamin, are you there, Benjamin? I don't see Benjamin. Brianna Carrillo. Hello, Brianna. Oh yeah, I've done the first equipotential so far. Okay, good. First equipotential, I'm gonna put 1 here, right? You're okay, you downloaded. Let's go to the next one. Elizabeth Castellano.
Hi.
Okay, did you manage to download your spreadsheet, Elizabeth?
Yes, and I plotted all of them already.
All of them, okay, good. All the 5. Okay, so now I want you to do the following, Elizabeth. I want you to make your graph look better, okay? Maybe you might want to change here the x-axis to regular number instead of scientific notation, okay? You double click on this x-axis and look for the number. See that? Category, you don't want scientific, you want regular number with 2 decimal places, okay? So you can maybe more, let's see, 2, 4, 6, 8. Okay, that's good. And you do the same for the y-axis, okay? Double click on the y-axis. You have this axis option. Make sure you click this bar chart, right? Go to, instead of scientific, highlight number and put, let's see how many we want to do. Put like 2 decimal places. Okay. Put it, don't forget that the y-axis and x-axis. Okay, so that goes for everybody, right? Let's go to the next student. Natalia. Are you there, Natalia? Let's see if Natalia arrived. No, Natalia's not here. Jacqueline Delgadillo. Jacqueline was here. She's no longer here. Yeah, that's not good. Okay, next, Jenny Diaz.
Yeah, I downloaded it and I plotted like 2.
Uh-huh. You plot two equipotentials, you said?
Yeah.
Okay. Okay, so keep on working there until you plot all of them. Valerie Diaz, are you there?
Yes, I'm here.
How many equipotentials have you plotted so far?
I have done 4.
All 4. Okay, so work on the other 2, right? And
Okay.
no, 5, right? It's a total of 5. Work on the last one, and I'll get back
Okay.
to you later on.
Oh,
One,
excuse me.
yeah.
Do you think you could show us the what's it called? The axis again?
The
And how to
axis, yeah, let's
change
do
it?
that again.
Thank you.
I'm going to undo everything that oops. No, I shouldn't do that. Okay. Okay, I'm gonna go back to what I have, okay, before, okay? Let's see. Numbers, scientific, 0. And that's what you had before. Most likely that's what you have, right? Can you confirm that with me? That how it looks like in the X and Y axis for you?
Yes.
Okay, good. So you go hover your mouse along those numbers in the x-axis, okay? Click it, and then you're going to see this number, this X labels highlighted. Okay? Do you see that in your computer?
Yes.
Okay, good. Now, double click. When you double click, make sure you click on this axis option. Okay?
Okay.
Okay, now go down here to number. We want to change the number of the axis. Open it up, see what is highlighted. Most likely it's highlighted the scientific there with 0 decimal places, right? That's what you have?
Yes.
Okay, so click down and highlight number. Now instead of scientific notation, we have numeric notation with 0 decimal places. You do not want 0 decimal places. You want at least 2 decimal places. I think 2 is a good number. It doesn't have to be more than that. Here you go. When I choose two decimal places, what do I have? 0.02, 0.04, 0.06 meters, okay? It's 2 centimeters, 4 centimeters, 6, 8, 10, 12, 14, okay? You want the display in this way. And then you do the same for the y-axis. Double click. We are already there at the place that we want. Change scientific to number and put 2 decimal places. Now we have 0, 1, 2, 3, 4, 5, 6, 7, and 8. 8 centimeters. Okay.
Okay, thank you.
Oh, and by the way, there's one more thing that you gotta do. Okay, so you change how the numbers in the axis are displayed, and now you want also to add a label to the axis. And how do you do that? You click on the chart. When you click on the chart, watch out, I'm going to unclick the chart. Look what happens here at the top. I'm going to unclick the chart. Whatever you had here at the top disappear, right? When I click the chart again, whatever you have here at the chart, it appears again. You're going to need that chart design and then add chart elements. And then you have all those options. What I want to do, I want to put the title to the axis. First to the primary horizontal, and then the primary vertical, right? I didn't change here yet. So what do you do here? You put X axis and put between parentheses the unit. Okay. And, you do the same here for the Y, right? I'm just copying X axis and then I'm replacing X axis with Y axis. And there's more. I think those numbers too small. I don't like those numbers because they're too small. We can increase the size of this number. Let's see if we can do that here. No, maybe it's label. No. Text option. Let's see. There is a way to increase. Oh, okay. We don't need to go here in the side panel. We can go here at the top. Okay. See that? Size 9. Font size is too small. Let us use 14 instead. And boldface it too to make it look better. And then you do the same, but instead of 14, you use a slightly larger. Instead of 14, use 16. The axis title should be larger font so you can distinguish more easily. And you repeat for this one. Click on the axis, 14, boldface, y-axis, 16, boldface. Okay, make sure you always put the unit for the axis. Okay, I'm going to correct for that once you turn in your spreadsheet. Okay. So here you go. What were you doing? 11:45, huh? We need to take a little break here. Otherwise, now what else? Plot to equipotential, the second equipotential. See,
Professor, I
okay.
have a question.
Yeah.
So your chart is going less than 0.14 and mine is going beyond 0.14. Is that because you have different numbers? We all have different numbers?
Let me see, which one, the x-axis or the y-axis?
Your x-axis.
X-axis. Oh, yours is going until which number?
So my fifth equipotential is at 0.16.
0.16. Which group are you? Check your spreadsheet group number there. G whatever.
Oh, G7.
G7. Okay, so let me check G7. I think there's no problem. There's no problem there. It's just a different set of data. Okay, most likely chose a different configuration. Let's see here, Y and X, right? Yeah, yours goes to 0.165. That's why you, right? That's why you're getting, here you go. Yeah, there's no problem, no problem. Most likely it's just a different configuration of the electrodes there in the plate. You don't have to worry about that.
Okay, thank you.
Okay, so here you go. What else you have to do? Label the axis and change the numeric type. Okay, that's what I did. Use font size 14 for the numbers along the X and Y axis. Use font size 16 for the labels of the X and Y axis.
Excuse me.
Yeah.
Do we delete the chart title?
Yeah, I don't like the chart title. I prefer the chart title deleted. Okay. Yeah, mine. You can see. You're never gonna see a chart title in my graphs. Okay, let's see. What time is that? Let's go another 5 minutes. So hopefully we'll go through every student. Next is Juan Escalera. You did everything, right, Juan? All the 5 equipotentials?
Yeah, I was able to download it and do the 5 graphs.
Okay. So now don't forget to format axis. Okay, format axis. Make sure you do that since you finish all the 5. Let's see. Yeah, let's go for our break now. 15 more minutes. And I see you. Here you go. Break. Okay. Break 11:50 a.m. to 12:05 p.m. Okay, and then after the break, I'll go through everybody else. I see you in any questions before we go to the break? Okay, so I see you in 15 minutes. I'm back. Here we go. Now, the next student in line here is Bianca, right? Hi, Bianca. Did you download the spreadsheet? Yeah, okay. And you have done three equipotentials so far, right? Okay, continue working on there, and then let's go to Dana. Hello, Dana. Is Dana here? Looks like Dana left. Dana Gomez. Yeah, Dana left. Okay. Next is Edwin Gonzalez. Are you there, Edwin?
Yeah, I've done 3.
3 so far?
Yeah.
Okay, continue keep on working on the rest. And then after working on them, just make sure you get the axis looking good, okay? Next is Eli Gonzalez. Hello, Eli. I see here in my clearly here in my list.
Yeah, I didn't hear you the first time, but I'm here. I'm done. I'm formatted. I'm waiting for the next step.
Okay, so you plotted all the 2, 4, 6,
Plotted all five.
all 5.
Put the labels, formatted to 14 point on the numbers and 16 point in the labels.
Okay.
Waiting for further instruction.
Okay, thank you. So let's see. Let's put another. Am I sharing my screen? Yes, I am sharing your screen with you. Okay.
Don't forget to record.
I'm recording. Yeah. Am I record? Let's see. Pause. Stop recording. Pause recording. Zoom recording. Good. And now let's see. Okay, I'll get back to you. Okay, let me check the other students and then I'll let you know what's next.
Sounds.
Oh, you know what? It's not that difficult. Okay, it's not that difficult. What you have to do now is to plot this graph right in here. Okay, just plot V average against X average. Okay.
You got it. Thank
Okay.
you.
So let's do this one now, and let's go to the next student. Manuel Hernandez Pineda.
Hello, I'm here, Professor. I finished all of them, and I'm also waiting for the next step.
Okay, you finished all the 5?
Yes.
And what about the formatting of the axis? Did you format the axis already?
Yes.
Okay, so now plot the second graph, okay? Just like I mentioned,
Okay.
second graph. The second graph is this one right in here, V average and X average, okay? So what is this V average and X average? You know, V average is you're going to take the average of those voltage values that my student measured, okay? And it's gonna plot against the X position here, the X average, which should be almost, you know, each of those X that you see here, they should be very close to each other. Because remember, the equipotentials are planar, right? They have almost the same X values. What changes the Y values? So what I'm doing here, I'm taking the average of the X positions, okay? And then you're going to see that that V average versus X average is going to be very close to a straight line. Okay, so let's add that to the label axis. Good. And now D plot the average along the y-axis and X average along the x-axis. Okay, that's the next step here. And I'll copy that so it looks good for, okay. 12:11, we have until 12:50. So 40 more minutes to go. Let's see who is next. Samantha? Is Samantha there? Nope, Samantha is not there. Faiz Hussein. I don't see Faiz either. Next, CJ. CJ Joseph. I don't see CJ Joseph.
Oh, Professor,
Yeah.
I wanted to do after the break, but I did 2 plots.
Okay, who is that?
Abir.
Abir. Okay. You did 2 plots. Okay, 2 plots, and you did download the spreadsheet. Okay, keep on working on that. And next one is Luis Leal. Luis Leal here. I don't see Luis Leal either. Next is Amber Lopez.
Hi. Yeah, I've done 3 graphs so far.
Okay, how many have you done so far?
3.
3. Okay. Okay, so let's try to plot as fast as you can, okay, because we're running out of time. And next, Adeli. Is Adeli here? No, Adeli is not here. Next, Genesis.
Hello.
Hello.
I'm here. I just came back from my in-person class, so I couldn't really get into the assignment for the lab. I couldn't find it on the
Okay.
on Canvas. Where is it under?
Yeah, it is on the grade book. Okay. Grade book of 17911. There are two canvas, right? One canvas is
Yeah.
7910 and the other 17911. If you want to 79, if you go to 17911, let's see, Genesis, right? Let's see.
Yeah.
Do you see your name here? I'm quite sure it's listed here. Genesis. Let's see. Genesis. Why is that? What's your last name, Genesis?
Lopez? It should be right there.
Oh yeah, here you go.
Yeah.
Yeah, so it is there, okay?
Under what did you say?
The spreadsheet is in there. You can download it to your hard drive. Did you download the spreadsheet?
It's under 7911 you said, and then
Yeah.
in
17911
is it called the six fig?
is called the Lab 1, Lab 01. Called the Lab 01.
Oh, okay, I found it right now.
Found it? Okay, good.
Yeah, okay, thank you.
So we still have to download it, and I put it here. Download, working on download. Mary, Michaelian?
Yeah, I downloaded everything and I plotted everything.
Everything, all the 5. Did you formatted the graph as well? Yes.
Yes.
Okay, now work on the second graph. Okay.
Okay.
You know what to plot in the second graph, right?
Yeah, the X average and the Y average, I already plotted that one as well.
Okay.
If it was just that one graph.
Yeah, just one graph. Make
Yeah.
sure it looks good, and not just plot, but also make sure you get the. Here you go. I'm gonna put here. Second graph. Let's see. Second graph. Plot and trend line as well. Trend line with R square. Okay. Do you know how to get that? The trend line with the R square. Mary, do you know how to get the trend line of the graph?
I know how to get the trend line. I'm not sure about the R.
Okay, I'll do it. It's in the syllabus, but I'll do it here. Here you go. We're gonna plot this graph, right, for everybody who's already there. Insert chart scatter. Do you see there's a straight line? That's no coincidence. It's a straight line. It is a straight line because of a uniform electric field. Okay, every time you have a uniform electric field, you have a voltage that changes linearly. And then what do you do next? You click one of the data points, right click it, add trend line, okay, and display equation chart, display R square value on chart. I spelled out that in my syllabus, how to get the trend line and the R square, okay? 1, 2, 3, 4, 5. But we'll get back to that. Let me check the other students. And Ramon downloaded, right, Ramon?
Yes, Professor.
How many did you plot all the 5 equipotentials?
Yeah, I finished the first chart and I did the equation and the R squared already.
Okay, so you finished the second graph.
Correct.
Okay, so you finished the second graph. So now you will start working on. We need to start working on the units. Okay, work on the units. And then after the units, I'll tell you how you're going to work on the sig figs. Okay, I'll get there. You still, I'll let you know how to work on the sig figs. You're going to need something else that you have to download. Okay, so let me see how Taylor is doing. How are you doing there, Taylor?
I downloaded everything. I'm working on the second chart.
Okay, good. Y, 5, Y, working. Good. Next, Genesis. Okay. Next is going to be Jeremy. How are you doing there, Jeremy?
I'm doing okay. I'm figuring it all out.
Okay, what have you plot all the 5 equipotentials?
Yes.
Okay, did you work out on the format of the chart with the axis and
Yep.
everything?
Mm-hmm.
What about the second chart? Are you working on that?
I'm about to here in a second.
Okay, so you're working on that. Stephanie?
I did all 5 graphs. I'm just fixing on the plotting thing. The thing you were just showing the last person, I can't right click it. I don't know how to do that. Like to make the line and then change the thing, I can't do that. I don't know how to do that.
So let me see. You plotted all the 5 equipotentials, right?
Yeah, now I just have to fix the format, but I don't know how to
Okay,
do
the
that.
format. Okay, so the format, you're having a problem like increasing the font size. Is that what the problem is?
Oh no, it was what you were showing the last person, like to make that line and get the
Oh, this one here?
yeah. Yeah, how do you, I
Okay,
don't
so
know how
you're
to do that.
so you're working on the second graph. Is that right?
Oh, okay, yeah.
This is for the second graph. It's not for the first graph, okay? Okay, so you're working on the second graph. Okay, so I'm going to do that again, okay? Here you go. You plot you have this plot here, right? Linear.
Yeah.
Click one of the data points, right click it, add trend line. Add trend line. When you go to the add trend line, this panel
Okay,
shows the right side. And then you click on display equation on chart, display R-square value on chart.
Okay, I just saw how to do that. I didn't know how to get the other side, but I just did it.
You got it, right? Okay, good.
Yeah.
So
Thank
let's go to the next student. There is one more student trying to come in. No, okay. So you finished this one. You're working on the second graph. Leslie Rios, are you there, Leslie?
Yeah, I'm here.
Okay,
I was
what are
able
you
to plot the. Can you hear me?
You're breaking up. Can you type there in the chat window?
That'd be a perfect example of actually that happening because that
Let me see.
kind of wanted me.
So Leslie? Okay, I was able to complete first and second charts. Okay, good. And Y and all the 5, right? And so work on the units now, since you finished the second chart. Did you get the R-square as well, Leslie? Okay, good. So need help with changing the numbers in the axis, you mean, right? In the X and Y axis? Okay, good. So let's do that again. Number in the, here you go. You gotta, I'm gonna do is the second graph, okay? Gonna do is the second graph. So you just do the same for the first graph. Double click. Okay, when you double click, you're gonna have this panel here on the right side. Okay, click here on the axis options, right? And now you have all those options, axis options, tick mark, labels, number. You want look at number. The category here should be highlighted as scientific. You don't want scientific. You want number, okay? When I put number here, notice that I have 0, 0, 0, 0, 0. Okay, we have only zeros here because I have no decimal places whatsoever. So you can put like 2 decimal places. Let's see how 2 decimal places is gonna look like. Yeah, look good. 0, 2, 0.02, 0.04, 0.06, right? Got it? And then you do the same here. Double click, change from scientific to number. And let's see, do we need, no, we don't need to put any decimal places in this case. Okay. And you're going also to change the font size. The font size is too small. Let's see if we can do that. Should be home. Yeah, should be on home. When you click here on this axis, you're going to see that the font, see that? And then the size is too small, 9. I want you to put 14, not just 14, but bold faced as well. And you do the same here, 14, bold-faced. Okay? And finally, you have to add the axis label. The axis label. Click the chart. All those two options shows up here at the top. You click on chart design, add chart elements. And that's going to be the chart title. Okay, first the X and then the Y. Primary vertical. And then you can change the font size as well. Okay. And bold face it, make it larger than 14, make it 16. And then you got it. Okay. So one more student, right? Let's see. What time is that? 12:24. We still have time. Let's see. Jason, are you there?
Yeah.
Okay, good. So tell me, what have you done so far?
So I have the form. I plotted all the points, all 5 of them.
All 5 of them.
I graphed the other. I did the second graph, and
Okay.
right now I'm just formatting it how you told us to.
Okay. Did you format the first graph as well?
Yes.
Okay, good. So you're doing well. Let's go for the next one, Hema. Hello, Hema.
Hey, yeah, I'm here. I finished the second graph, so now I'm formatting.
Okay, good. Format. Don't forget format. Let's put here formatted. And don't forget to work on the units, right? And 12:25. Let's see, we have 25 more minutes. And let's see. Copy and paste. Now, Cindy is here. I don't think so. Nuhamian is not here either. Okay. Okay. Now let's go to the top, right? Circle back here with Abir. How are you going there? How are you doing there, Abir? Looks like Abir left, huh? I'm gonna put it left. Next is Nestor. Are you there?
Yeah, I am.
Okay. Did you plot how many graphs how many equipotentials have you plotted so far?
3.
3? Oh, gotta go faster than that. Okay. So
Well, it's because I had a trouble with, because on yours Excel it says the select data months is a little different. That's why it's kind of hard for me to figure it out.
Okay. Do you have a Mac? What do you have?
I have a Chrome.
A Chrome. Oh, okay. The Chrome is a problem. Yeah, the Chrome is. Well, try to. Yeah, it's a little bit more difficult, but you are moving forward, right? You are advancing on that, right?
Yeah, I just have to figure it out because it is different.
Yeah, Chrome is more difficult than Windows. Okay, so I'll get back to you. Let's see how Monte is doing. Monte, how are you doing? I can't hear from Monte. Okay, I'm gonna put a star here on Monte's name. Let's go for Hasty.
So same problem with me. I have a Chrome, so I'm figuring out how to do it. Like,
Okay. So how many equipotentials have you plotted so far?
I'm on the last one.
Oh, you're in the last one, the second graph, or the
No, the first one. First
the
one.
fifth equipotential.
Yes.
Okay, so let me write that down here. You have a Chrome, and the other student who has a Chrome is Monte, right? No, it's not Monte. It's Nestor. Chrome.
Yeah, me, Nestor.
Yeah, see if you. Yeah, I encourage you to try to find another computer because the Chrome is really tricky. Okay, so Isabella is not here, right? Next one is Justus. How are you doing there, Justus? I have to go back to Monte as well, right? Monte, are you there, Justus? Give it. Okay, so let's go back to Monte. How are you doing there, Monte? How many equipotentials have you plotted so far? You can type there in the chat window, Monte. Okay, you're in the third one. Okay, okay. So try. Oh, okay. So try to finish it quicker. Okay, so let's go for the next one. Justus, give me Justus another opportunity. Hello, Justus. Okay, Justus is not responding. Going for Brianna. How are you doing there, Brianna? How many equipotentials have you plotted so far? I have finished with both graphs. Oh, good. So 5 equipotentials. You formatted the axis. You finish the second graph. And now you have to format the second graph. I presume that you have finished too, right? And it now works on the units. Work on the units, and I'm gonna tell you what you have to do for the sig figs. Okay, sig fig. That's F. Sig fig. Let's see if we have time to cover the sig figs. Next is Elizabeth. Elizabeth, finish all 5. Did you
Yeah,
format?
I'm working on formatting the second graph.
Okay, you're formatting the second graph, so you're working on
Yes.
that. You got this. Did you get the trend line as well of the second graph?
Yes.
Okay. Trend line. Let's put trend line here. Trend line. Okay. So next is Natalia Cordoba. Is Natalia here? No, Natalia is not here. Jacqueline Delgadillo. Looks like Jacqueline left too, right? She was here earlier. I'm gonna put it left. Next is Jenny Diaz. How are you doing there, Jenny?
I'm formatting the second graph.
Oh, good. So let's see. So you formatted the first one. Now you did the second graph. You get the trend line too, trend line and R
Yes.
squared. Okay. And now you're formatting. That's good. So let's go for Valerie now. Valerie, how are you doing there?
Pretty good.
Okay. Did
I already finished plotting the things I had to plot.
Okay. So you formatted the first graph, right? You plotted the
Yes,
second
I did.
graph. You got the trend line
Yes.
of the second graph too?
Yes.
And now, did you format or are you still working on the format of the second graph?
I did format that one too.
Oh, okay, you already formatted. And now, what about the units? I want you to work on the units. Have you finished the units?
Okay. I have not.
Okay, good. So work on the units. The units are here, right? Here you go. I'm going to highlight for you all. Those are the units. Here you go. Okay. 1, 2, 3, 6, 9, 12, 14, 16, 17 cells. Okay. And there's more, right? There's more stuff here. Looks like we have to continue this next week, huh? But let's see how far we can go today. And then the second lab is going to be quite similar to that. The only difference is that it is going to be a different electrode configuration. A different electrode configuration. Let's go for Juan Salvador. Where are you right now?
I'm
Juan
here.
Escalera.
Hello?
Yeah?
Yeah, I just haven't done the sig figs or the units.
Okay, so you finish the units, right? And I have to tell you how to do the sig figs. Let me finish with everybody, and then I will orient everybody how to do the sig figs, okay? Bianca. Are you there, Bianca? Yeah, okay. Where are you right now? At the lab? I presume you finished the first graph, is that right? Okay, I need you to work on the plot, okay, and I will give a little bit more of time. Let's go for Dana. Dana is here. No, Dana is not here. Left, right? Dana left. Next, Edwin Gonzalez.
Yeah, I'm here.
Yeah. So did you finish all the 5 equipotentials, Edwin?
Yes.
Okay. What about the format of the axis?
I'm just waiting on the units part.
On the
Oh,
unit.
sorry.
Okay, so you did everything and now you're working on the units, is that right?
Yes.
Okay, good. So let me write that down here. Next, Eli Gonzalez.
Both plots are done. Everything's formatted, including trend line and R squared. Units are done except for one because I'm just unsure of what the unit is, but the units are done. And sig figs, I don't know what you're asking for.
Yeah.
So that's all.
Sig figs. I gotta give you something before you can do the sig figs, okay? So hang in.
Thank you.
Okay, and let's go for, and by the way, the units, there is more, it's not just those ones that I mentioned. There is, there are units right in here as well, okay? Units for the slope and the E field. Okay, so start thinking how you're going to do that. But again, it seems that we'll have to continue that next time. We have 15 more minutes to go. Let's see. Manuel Pineda, how are you
I'm
doing?
here. I finished everything, and I'm also just waiting on the units.
Okay, you finished everything, including the units, right? And you're waiting for the sig figs?
Yes.
Okay, you're waiting for the sig fig. Okay. Now, Samantha is here. No. Okay, Samantha, Faiz Hussein, CJ, I don't see. Luis Leal, I don't see. Next is Amber Lopez. How are you doing there, Amber? I don't see Amber here. Looks like she left. Okay, left. And Genesis?
Hello, I'm here.
Were you able to finish
I'm just working on the graphs. I need 2 more, and then I'll be done with that.
Which one are you working on?
The plotting?
The first one?
Yeah, I see that I joined in a little later to download the graph.
Okay. And you're downloading the graph, is that right?
No, I already downloaded it. I'm working on the graph. I have 2 more plottings to do.
Okay, so you plotted 3 equipotentials so far, is that right?
Yeah.
Okay, good. So let's go for the next one, Mary.
I finished everything, just waiting on the sig figs.
Okay, trend line, format, unit, that's good. And Ramon? Are you there, Ramon?
Yeah, I'm working on the last parts, the units and the sig figs.
Which one?
The units and the sig figs.
Oh, the units. Okay, let me put W here for work. Good. And Taylor, how are you doing there?
I'm just working on the units and the sig figs.
On the units? Okay, good. Next is Jeremy. Hi, Jeremy. Are you there?
Hello? Yeah, I'm here.
Okay.
Yes.
What are you doing right now?
I'm still working on my the
second graph
until this evening.
Okay. Let's see. Okay, Jeremy is still working on the second graph, is that right? Okay, so don't forget, next is going to be the trend line. Let's go for Stephanie.
I still just have to do the sig figs and
Okay, so you finish everything until units, right?
I'm still like on the second graph still, but I still need to do the other three.
On the second graph. So let's say you're working on this. Did you get the trend line for the second graph or not yet?
Yeah.
Oh, you did. Okay, so you finished the second graph, and you got the trend line. Did you format the second graph as well?
No.
No. Okay. So working on that and the units. Are you working on the units?
Yeah, I'm working on that too.
Okay.
I have a question. When is this due?
Okay. Well, it initially due for next week, but it looks like
Oh,
we
next
have to postpone for another week. Okay.
Okay, thank you.
It looks like you have to postpone for another week. Let's see. Let's go for Leslie. Leslie Rios.
I was able to complete everything.
You did everything?
Yeah, just waiting on the pictures.
Yeah. Just waiting for the sig figs, right?
Yes.
Okay. So Jason.
Yeah, I got the sig figs done. And I got everything done, yeah.
But the sig figs, right?
No, I did do the sig figs, yeah.
Do you okay? You need a chart that I didn't to do the sig figs. You're going to need a chart, okay? That I'm going to provide to you.
Oh, okay, I'll fix that when it's time then.
Okay, so Hema Torres.
Yes, I'm all done. Just waiting for the
Hold on.
sig figs.
Waiting for the sig fig. Okay, so let me get the sig figs now. Sig fig. Sig fig. Okay, that's the one. You're actually gonna need 2 tables that I'm gonna upload it right now to Canvas. Okay, I'm gonna write that down. P07 sig fig. And you're going to need 2 tables. The sig fig here and the confidence level. Okay. So I'm going to upload right now. Dashboard courses. This one.
It looks like it's already there in the home section.
Yeah, it's
unless
possible.
they're different.
Yeah, it's very possible. Let's see. Oh yeah, it's here. I don't upload that. I forgot about that. Yeah, okay. So let's talk about the sig fig, okay? We still have 10 more minutes to go. Download this sig fig to your hard drive. And let's take a look at this. There's more than one table here. 1, 2, 3, 4. 4 tables, 4 different tables. In this lab, you are worried about this table right in here, voltage. Okay, we are not going to use the other tables in this lab yet. We are going to work on those tables in the other labs. For this lab, you have to look at the voltage of the DMM. Okay? And the way you read that is the following. If your voltage is between this value here, 10 to minus 5 volts, and 9 times 10 to minus 5 volts, you have to display just one sig fig, okay? If it's between those 2 values, it's going to be 2 sig fig. Okay? What's your minimum voltage that you have there in your tables? Let's take a look, right? It's going to be around 1 volt, right? So here we go. Oh, no, it's going to be 2 volts. Yeah, the lowest one is going to be around 2 volts. 2, right? So what you have to do, you have to worry about, either this row or this row, depending on the values that you have there, okay? Make sense? I'm gonna give you an example. I'm gonna give you an example here for group 9. This value here that I have at the very top on group 9 is 2.001. 2.001 falls between those two values. Consequently, you're going to end up with 4 significant figures. Okay? Don't forget, it's 4 significant figures, not 4 decimal places. So what do? You go back to, here you go, to this one. I'm going to display 4 significant figures, and I have to change the format of this number. Click on the cell, right-click it, and go to Format Cell. Instead of scientific, now you're going to display numeric format. And here's the sample that you have. That's how it's going to look like. At this moment in time, you have 0 decimal places. 0 decimal places correspond to 1 significant figure. If I increase the decimal places to 1, now you have 2 significant figures, right? How many significant figures do you want? Go back to the table. Between 2 and 9.999 is 4. So I have to display 3 decimal places. And now I have the measurement with the right number of significant figures. Okay? I can do everything. I can do, you don't have to do one by one. Okay? You don't have to do one by one. However, you got to be careful. If you want to do everything at once, okay, you got to make sure that they all lie within the same range that you saw in that table, right? Looks like everyone is between 2 and 9.999, okay? Yeah, everyone. So to save time, what you're going to do, you're going to highlight everything at once. Suppose that you have that, right? And format cell, number, and 3 decimal places. And now I have everything displayed properly. Okay? Everybody got it? X and Y is, you don't look at the table. X and Y is a very important piece of information, okay? The material, one of the materials for this lab was a ruler, okay? So in order to display the X and Y with the proper number of significant figures, you're going to use the resolution of the ruler, okay? For sig figs of X and Y, comma, you use the resolution of the ruler, which is 1 millimeter, which is 0.1 centimeters, which is, everything is in meter, right? 001 meter, okay? Here you go, you're going to display X and Y up to this decimal place, up to the 3rd decimal place. Make sense? Remember, we are using the resolution of the ruler. As an instructor, I'm a little bit more conservative about the sig figs. So I'm not using half of the smallest size of the ruler, right? I'm using the actual resolution of the ruler. Some instructor teaches like half of the smallest division. Okay, I prefer to use the smallest division instead of half of the smallest division. Makes sense? So here you go, X and Y. You're going to display up to the 3rd decimal place. Format cell, you gotta format as a numeric 1, 2, 3. Okay? And everything else, everything else here is going to be 1, 2, 3. 3 decimal places because we're dealing with the ruler. And format cell, number, 3 decimal places. Okay, and now you have to do the rest for the 4 volts, 6 volts, 8 volts, and 9 volts. Okay, now let's see. Yeah, okay, good. Now I have some good news for you. I have some good news for you. Two more minutes to go. What is the good news? The good news is that, remember, voltage values between 2 and 9.999, they all have 4 significant figures, right? So every value here of the voltage will be within this voltage range, okay? So they will all have the same number of significant figures. So we do that, right click. It's not all the time that something like that's gonna happen, right? But in a way you're lucky. Here you go, number. We're gonna put 3 decimal places. 3 decimal places correspond to 4 significant figures. Number of decimal places is not necessarily the same as the number of significant figures. Remember that? And then here you go. We got it. Okay. 1 minute to go. So I think we're good. I covered significant figures, and we're going to continue this lab next week. There is there's nothing much left here. The only thing that's left is the confidence level and this table. Okay, and I will postpone the date of this lab report. Okay, for another week. Any questions? Let's see.
Yes. Would we also format table 1.2?
1.2. Oh, yeah, we are going to get there next week. Okay. I want to do that next week.
Okay.
Okay. I will cover that next week because there won't be time. But you can think how to do that because, it's not difficult to figure out, right? Because the X average is what? The X average is the sum, right? Divided by a given number. Right? So what happens when you sum? So what this one here, this one is the sum of all of those divided by 6, right? When you sum all those numbers, what happened to the number of significant figures? What happened to the number of significant figures when you sum all of that? I'm going to sum here for you. You preserve the number of decimal places, and as a consequence, we add on the number of significant figures, right? What was 4 significant figures now become 5 significant figures. Make sense? Okay, so you have to display 5 significant figures here. Oh no, sorry, not here. Here, 5 significant figures here for the V. And then you gotta do the same for the X, okay? Gotta do the same here for the X. So out of 2 significant figures, you have now 3 significant figures. Okay? But I will repeat that next week. Any more questions?